Okay, we are recording. Hello, my name is Sergio Garcia. This is the video for chapter 2 of part 1 of the test. I'm going to be going over all the important things I saw for chapter 2 that'll help benefit me going through on the test. So, chapter 2, while being very math intensive compared to chapter 1, I feel, boils down to only a couple essential equations that help you understand what's essentially kinematics, discussing motion, displacement, velocity, acceleration, all in like a singular dimension or two. But yeah, so I'll go through these and I'll explain them. So first we have our sort of core right here. So the first thing you should know is displacement. Which is demarked with the change in x as a vector. This is whenever you have a velocity versus time graph. It is the simplest graph. It just shows you where an object is in relation to time, and it tells you if it moves back or forth. So the next thing we have is velocity, which is the slope on a displacement graph. It is demarked by the change of x, right? So the displacement over the change in time. So velocity is essentially displacement over a certain interval of time. And it is on a displacement graph, it would be the slope of the line at any given time. And on velocity graph, it's just the point. And it tells you how fast or like what the rate of the object displacing is, or I guess how fast it'd be moving. And finally, there's acceleration, which would be the slope on a velocity graph. That is demarked by the change in velocity over the change in time. Essentially what this means is acceleration is how fast the object speeds up or slows down. It'd be the change in speed, essentially. And that's like the general understanding. There's 3 separate graphs for each of these, depending on your equation. It's important to understand the differences between the 3. Also, if you integrate whatever you have for acceleration, it'll give you your velocity. And if you integrate your velocity, it'll give you your displacement. So for kinematic equations, these are equations that will allow you to like solve generally like word problems. Essentially that you can handle, let's say for this first one, it shows displacement equals to average velocity times time. With this, you could, let's say you were given the distance that something travels, right? And its average speed, right? If it's traveling at an average speed, maybe like a constant rate, and the distance that it travels, you can manipulate this to have it equal your change in position divided by your average velocity, and you could find your time with it. Alternatively, you could find your average velocity by dividing your change in position by time, and we see it over here. Velocity equals change in position divided by time, your change in time. So again, very useful formula. Typically going to be helpful in a lot of word problems. Next, we have a more complex version of it. For here, we have our change in position or displacement is equal to our initial velocity times time plus 1/2 of our acceleration times time squared. This will be helpful when we don't have an average velocity, or let's say we're given the initial velocity but the velocity is like a curve, right? So if the line isn't straight, like this, if it goes the velocity of a graph, let's say we have, we're going to do black pen, draw, we have position versus time graph that looks like this, right? It's like going, this is a parabola. If they give us our initial velocity as an upward movement of 10, obviously the velocity is a slope, right? So we can't tell how this goes because you see the slope is changing at each of these points. So since the velocity can't be calculated as an average as easily, you take the initial one and multiply it by whatever time value it is, and then add 1/2 of our acceleration, which they'll give you, times the time squared. And those are the situations where you'd want to use that equation instead of our first one. Nextly, we have this one. This one's helpful when you're not given time. This is the only one of these equations that does not have the variable t. So essentially what this will help you out with is, let's say you're given your final velocity, your initial velocity, your acceleration and displacement. You can work it by taking your final velocity squared equaling to your initial velocity plus 2 times your acceleration times your displacement. It's relatively simple. Again, use this in situations where you do not have your time variable and you have everything else. You can find your final velocity, you can find your acceleration, and you can find your displacement with it. Very useful formula. And finally, you have your final formula, which is when you don't have displacement. This is the only one that does not have displacement inside of it. So you take your final velocity equaling to your velocity initial plus your acceleration times the time. And you can work with that. You can manipulate it any number of ways. Essentially, what this is a manipulation of this formula right here. And what I mean by that is you can move, let's say you start off with your v equals v0 plus a times t. So what that would actually look like is you'd end up having v minus v0, if you move that over, equals to at. Now this is going to look a little bit similar, because then you'll have a equals to v minus, v0 over t. And if we remember correctly, v minus v0 is your change in v over t. So this equation right here is really a manipulation of this one by means of this algebraic formation, I would say. So yeah, you manipulate this to equal this using this work right here. And finally, we can go over our free fall equations. These will be helpful in questions where they tell you that you're dropping something from a fixed position. Let me quickly erase before we get into that. And we'll use pink. Okay, so typically with free fall equations, it's always constant that your acceleration is going to equal to negative 9.8 meters squared. That is how gravity works in our, on our planet, and it is always going down, right? It's in the negative direction. Velocity always goes down because even though like our Earth isn't exactly flat, we treat it like it is to calculate physics in this scenario. So it's important to note that this acceleration of negative 9.8 meters per second can be broken down into 2 different pieces. Its x and y component. Since it's going straight down, its x component is 0, and its y component is negative 9.8 because again, it's going straight down in the y direction. So now let's essentially find our components of like velocity. We kind of just integrate both. So if you take the integral of just a flat out 0, you'll just add a variable to it. So your v of 0 x, right? That's your variable of whatever you just integrated. And then for y, since you have a constant here, you add a variable to it, which is t, and then plus your constant, which is v0 y for the y direction. Now if you integrate that again, you get for x, you get so when you integrate acceleration again, you get your velocity. You integrate this to get this. You integrate this to get this. You do that once, and then you integrate a second time using this to get your x's position, and it'll give you your v0 of x to times t plus a new constant, which is your initial position of x, and then your displacement of y in terms of time will be negative 9.8 t squared over 2 plus your velocity of y times t plus your initial y as your constant. Again, when you integrate your v of x, you'll get your x. And when you integrate your v of y, you'll get your y. So when you look at free fall, you can either have all these equations memorized. You can either have all these equations memorized if you would like, but also if you're like feeling nervous on a test, you can always just integrate these things, write them down on your paper, and just figure them out mathematically before starting any question. And those are essentially the main things you need to know for this chapter. It's kind of bare bones, but that's just because all of these equations have so many applications that are really helpful in almost any scenario. If you know these, typically you'll be fine. So yeah, that's everything. Thank you for watching.